viewers, here's a question on quadratics. The first question reads, if alpha squared and beta squared are root of x squared minus 21x plus 4 equals to 0, and alpha and beta are both positive, find Roman numeral 1, alpha beta, okay, Roman numeral 2, alpha plus beta, Roman numeral 3, equation with root 1 over alpha squared and 1 over beta squared. Alright, so the second question is, if alpha plus beta is equals to 5 and alpha beta equals to 2, so we're asked to calculate this and also determine the values of m and n such that this has this root. Okay, now, so let's do it this way. Okay, for the first question, we have for A, we have Roman numeral 1, Roman numeral 2, and Roman numeral 3. So let's do this way. Now we're given that alpha squared and beta squared are roots of x squared minus 21x plus 4 equals to 0. So using the Vieta's formula, okay, using the Vieta's formula, we know that sum of root will be alpha squared plus beta squared, which will be negative b over a. So from here, we know that the value of a is what? 1, because a is the coefficient of x squared. The value of b is minus 21, because b is the coefficient of x. And then the value of c is 4, because c is the constant term. All right, so the sum of root in this case will now be squared of alpha plus beta squared will be equals to negative, that will be minus negative 21 over what? Over 1, yeah. So this will be equals to 21. Okay, that will be equals to 21. Then product of root, that will be alpha squared multiplied by beta squared. Okay, so product of root is, when we say product of root, that will be c over what? A, where c is 4 and a is what? 1. So product of root will be equals to 4 over 1, and that's what? 4. Now, but in the question, we are told that alpha and beta are both positive. So which means in this case, to be able to find the value for alpha beta, then it means we have to take the positive square root of 4. Okay, so here we can write this as alpha beta raised to the power of 2 equals to 4. Okay, so that we can say alpha square root of alpha beta raised to the power of 2 and then the positive square root of 4. So alpha beta equals to 2. So which means the value of alpha beta is 2. So this is the first answer. Okay. Now, for Roman numeral 2, let's do that here. Now for Roman numeral 2, okay, Roman numeral 2, okay, we want to obtain the value for alpha plus beta. So to obtain the value for alpha plus beta, we know that alpha plus beta squared is equals to alpha squared plus beta squared plus 2 alpha beta. So which means that we know from here that alpha squared plus beta squared is 21. So we can then write alpha plus beta raised to the power of 2 equals to 21 plus 2 multiplied by alpha beta, that will be 2. So this will be 21 plus 4, which is equals to 25. So to get the value of alpha plus beta, so alpha plus beta raised to the power of 2, we take the positive square root of that, and then this positive square root of 25. So alpha plus beta equals to 5. Remember, alpha and beta are both positive. So which means to get the positive, because they are positive, so it means we need to take the positive square root of, both sides. So, and that's exactly what I did here. So which means we're only considering a positive solution. So which means the square of alpha beta will be equals to square root of 4. And that's why we have alpha beta to be equals to 2. Then in this case, their sum will be equals to 5. Okay. Now, Roman numeral 3. Roman numeral 3. We are asked to what? Find the equation whose roots are 1 over alpha squared and 1 over beta squared. Alright, the equation whose roots are 1 over alpha squared and 1 over what? Beta squared. That will be, we know that to construct a quadratic equation with roots 1 over alpha squared and 1 over beta squared. So let's use the general formula. We have x squared minus sum of roots of x plus product of roots, and that will be equals to 0. So that will be x squared minus 1 over alpha squared plus 1 over beta squared multiplied by x, then 1 over alpha squared multiplied by 1 over beta squared equals to 0. So this will be x squared minus alpha squared plus beta squared over alpha beta squared, okay, multiplied by x, while this will be 1 over alpha beta raised to the power of 2 equals to 0. Now, we know that alpha squared plus beta squared is what? 21. So this will be x squared minus 21 over, now alpha squared beta squared is the same thing as alpha beta raised to the power of 2, which is what? 4. So this will be over 4, then x plus 1 over, we have the same thing, that is 1 over alpha beta raised to the power of 2, that will be alpha squared beta squared, and which is what? 4 equals to 0. So multiplying this equation by 4, this becomes, when this is multiplied by 4, this becomes 4x squared minus 21x plus 1 equals to 0. So this is the required equation. That's the required equation. And we're done with question A, Roman numeral 1, 2, and 3. Okay, question B. If alpha plus beta equals to 5 and alpha beta equals to 2, calculate 1 over alpha plus 1 over beta, okay, and hence determine the values of m and n such that x squared plus mx plus n equals to 0 has roots, okay. All right, so the first thing we need to do is to calculate what is the value of 1 over alpha plus 1 over beta. So that means, of course, we are giving alpha plus beta, which is equals to 5, alpha beta equals to what? 2. Now, we want to calculate 1 over alpha plus 1 over beta. So let's simplify this. Simplifying this, we're going to have alpha plus beta over what? Alpha beta. Now we know that alpha plus beta is what? 5. Then alpha beta is what? 2. So that is the value of 1 over alpha plus 1 over beta. Alright. So next, we want to what? Determine the values of m and n such that x squared plus mx plus n is equals to 0 has roots of that. That means we need to construct a quadratic equation using the root, using 1 over alpha and 1 over beta as the root, okay? Now, that is to construct a quadratic equation whose roots are 1 over alpha and 1 over beta. So which means, so that will be 2. Let's give this Roman numeral 1, Roman numeral 2, okay? Now, to determine, let me put it this way, to determine the values of m and n, okay, with the equation x squared plus mx plus n equals to 0. Yes, we have here that such that this plus this equals to 0 has roots, okay? Having roots 1 over alpha and then 1 over beta. So which means with this, we know that 1 over alpha plus 1 over beta, that is the sum of roots. This is the sum of roots. And we know the value for this, 1 over alpha plus 1 over beta, to be equals to 5 over 2. Okay, then also product of roots. Product of roots is 1 over alpha multiplied by 1 over beta, which is same thing as 1 over alpha beta. Now, 1 over alpha beta. Now, we know that alpha beta is 2, okay? So 1 over alpha beta, this will be 1/2. Okay, so the equation, remember, we're using this, okay, to construct a quadratic equation. So we're using the equation, let me write it this way. The equation required will be x squared sum of root of x plus product of root equals to 0. Now, we know our sum of roots to be 5 over 2. So this will be x squared minus 5 over 2 times x plus 1/2 equals to 0. So this becomes x squared minus 5x over 2 plus 1/2 equals to 0. Now, we can multiply this equation by 2 because we want to write this equation in a what? As a standard quadratic equation. All right, so multiplying the equation by 2. That will be 2 times x squared, then 2 multiplied by 5x over 2, then 2 multiplied by 1/2, 2 multiplied by 0. So this will be 2x squared minus this will cancel this, then 5x, this will cancel this, plus 1 equals to 0, because 2 times 0 is 0. So looking at this equation, so it means that the value of m will be 5, and the value of n will be what? Will be minus 5, and the value of n will be 1. Okay, now let's do it this way. Let's divide 2 by 2 because it's meant to be this way. So we have x squared, okay, here, minus 5x over 2 plus 1/2 equals to 0. So we have what looks like this now, okay, because the coefficient of x must be 1, x squared must be 1. So in this case, the value of m, so this is the equation. So the value of m is minus 5 over 2, and the value of n is 1/2. Let me write it again. M equals to minus 5 over 2, n equals to 1/2. These are the values of m and n required for this question. We are asked to determine the values of m and n, such that x squared plus mx plus n equals to 0 has root 1 over alpha and 1 over beta. The noblest pleasure is the joy of understanding. Bye-bye.